Never mind. I'm sorry. That's a
Al Qaeda operations in Pakistan would be working. Where would that be? It's like, oh, President Reagan.
Oh, well,
he's in
if you
missile.
were looking for it, it would be here, right here.
Hangs up. We sent 47 cruise missiles in the middle of the night and killed the janitor.
So, first few days, we're going to talk just about sequences, and then we're going to morph this over into series at this level. So like if I were going to do it like an introductory blast on sequences, in an Algebra 1 class, I would take several days. In a class like this, we're gonna cover a lot of ground pretty quickly because it's not going to be anything that's hard. But the biggest hang up with sequences is the notation, the things you're going to see. But it's just language. You're used to that. Funny things that look funny, symbols that are like, weird. It's no big deal. Just quickly before we get into actually just running through some problems, a sequence is a list of numbers. And so I don't know how to really explain this to you without like writing one down. So a sequence is like, 1, 4, 7, 10, comma, dot, dot, dot. So when I list it out as this, then this, then this, and then I'm not doing anything mathematical per se with the numbers, that's called a sequence of numbers. Okay. And then a series, you've probably never talked about this at any point before. A series is when you take elements, either full or partial elements of a sequence, and you add them together. And so we're going to see, I can't believe I have to say this out loud, but we are eventually going to start using this notation. And you might know what Greek letter that is. Zach wants to say it so bad. Go ahead, Zach.
Sigma.
That's a sigma, right? And so, darn. So when we get into series here in a couple days, a series really don't get too confused by the verbiage. A sequence is just an explicit listing of terms. And then the series is if we want to sum a certain portion of the terms. Okay, so a sequence is a listing, a sum, I might say, or a series, I might say, find the sum of this of the second through the 31st terms. And that becomes a series when we're doing a summation, okay? So the sigma, the Greek sigma, that's a capital sigma, I believe is what that is. That is the notation for what we call summation. All right. So anyhow, today we're not going to talk about series at all, and we're just going to talk about sequences. And there are two types of sequences that we're going to talk about, and the two subtypes are arithmetic and geometric. For the record, if you change this word that I'm underlining into a noun, it means something else. It's called arithmetic, right? That's the noun. But when you use so yeah, the word arithmetic is like a noun. It's a thing. Like, oh, he's working on his arithmetic. When you change it to an adjective, like a descriptor, you have to change the pronunciation. So now you put the emphasis on the second syllable.
Arith-
No, third syllable. So instead of arithmetic, it's arithmetic. And so you just change your pronunciation. Not most people would be like, why do I care? And the answer is, I don't actually know. But we're going to deal with arithmetic and geometric sequences. So arithmetic sequences are sequences that have what we call a common difference. And the word difference in mathematics, of course, refers to subtraction. A geometric sequence is a sequence in which the terms have a common ratio. And the word ratio, of course, refers to division, fractions. So the one I wrote up there in red is an example of what we would call an arithmetic sequence. Why is that?
They're all three.
Because I'm adding three, right? I'm not dealing with anything multiplicative or
Yeah.
dividing or anything like that. So because I'm adding the same number each time, and it would work the same way, by the way, if I was going the other way. I could also start at like 15 and then go 5, -5, -15. You can see that I'm subtracting 10. So whether it's addition or subtraction, both are defined to be arithmetic. So rather than call that a subtraction sequence, we would say that we are adding -10 each time. Not a big fan of adding negatives, but in this case, you'd want to pick that verbiage. So clear on what an arithmetic is? Okay. And then the geometric is a multiplicative issue, and it sometimes will feel like a division issue. But the most obvious one would be something like this. Like I could do 1, 3, 9, 27, dot, dot, dot. And when you see those ellipses, that's just a common notation for, and so it goes forever. Correct. Ellipses, not ellipses.
So
Thank
is
you.
the
Yes.
method arithmetic kind of like the hyperbola situation?
Yeah, sure. So the
We should say it one way.
the common ratio in a case like this is what we multiply by to get from one term to its the next one. And so in this case, we would say that R is equal to 3. So the common, I'm going to switch back to purple so I'm consistent. The common ratio is what you multiply by to go from term to term. What just happened?
All three of them spread at the same time. Started and stopped.
Are you serious?
All
Implicit matrix, they both.
Christian and you both yawned. It's so funny.
I'm so tired I didn't even notice. So with a geometric sequence, we will refer to the common ratio as R. It's just the notation that you have to use. And with an arithmetic sequence, we refer to the common difference as D. And so in our first arithmetic sequence, we would refer to this and say that, okay, so D equals positive 3. I want to be done. And then in the second one, we would say that the common difference is what? Negative 10. Good. And finally, before I kind of embark on the mathy part of this, not all sequences are arithmetic or geometric. So part of what you're going to be asked to do in this assignment is sometimes just identify a sequence that's neither. You know, it's not arithmetic and it's not geometric. So in a case like that, and by the way, there's no crossover. Like there's a page of arithmetic and then a page of geometric. And so the question would be like, well, it's not really a question, it's more of a statement. Determine if the sequence is arithmetic. And if you see something that fails, so like if it starts looking promising, like -2 and 9, what did I add? 11. And then I add 11 more and I get 20. And you're thinking, oh, I'm in like Flynn, right? This is easy. And then I get 32, dot, dot, dot. I wouldn't, anything else that I would ask you to do, finding the 30-second term, writing the explicit or recursive formula, none of that is going to apply because you would just write, sorry, this is just not arithmetic. And that's where we would stop. Like there's nothing beyond that. Okay. So watch out for those. In the arithmetic page, there's going to be a couple that aren't arithmetic. And on the geometric page, there'll be a couple that are not geometric. And you just say not arithmetic, not geometric, and move on your way. Yes, sir.
So like in a sequence, if it like started with 1 and then the next number was like a +2 times 30 kind of thing, and then it kept doing that, what kind of sequence is that?
+2 times 3.
Yeah, like say it's 1 and then it's like 9 and then it's like 33.
I don't know what I would even call that. I don't know if it has like a name, an official name.
So it would be just say that.
I mean, there's another sequence and let me be a little bit less ignorant about it and maybe I can look into that for you. But I mean, like, have you guys ever heard of the Fibonacci sequence?
Yeah, the spiral thing.
Yeah, so the Fibonacci sequence, I believe, starts with a 1 and then another 1 and then there's a 2 and then there's a 3. And what comes after that? A 5 and after that, an 8 and after that, 13 and after that, so on and so forth. And so
Plus the second number.
right. So any two terms, every term is the sum of its two predecessors, right?
Mhm.
The point I'm trying to make is that not all terms are arithmetic. Nope. Not all sequences are arithmetic or geometric. Sometimes sequences are just whatever. Is there necessarily a name for all of them? Let me look into that. I don't know. This one has a name, but I don't know what other names there would be. So the idea here today, my goal, talking more than I wanted to, was to get you to be able to write what we call explicit formulas for sequences. Listen, the idea is if I gave you, so like take this one that I'm putting in a yellow box up here. If I asked you to find the 8th term, would you have any problems with that? No, of course not. You would just add 3 a few more times and go, oh, there it is, I found it. But where we run into troubles is what if I said, what's the 834th term? That's when it becomes like, oh, okay. And you're all super smart people, so you could totally problem solve and work around, even if I didn't show you a formula, you could figure it out. But we want to have what's called an explicit formula, and it gives us, let me tell you what it is for arithmetic. Write this down. For an arithmetic sequence, the nth term of a sequence can be arrived at by taking the first term of the sequence and adding the product of n minus 1 and d. And that's what I cautioned you about, is that for about a minute you look at that and think, oh my Lord, this is going to be difficult. And then you realize it's not bad. So let's talk about our cast of characters here. N simply refers to what I want. So like if I wanted the 54th term of a sequence, then I would simply be calculating like a to the 54th. Got it? So don't be freaked out by that. The other characters along the way are a sub 1. And I said it as I went, but what is a sub 1?
The first one.
It's the first term. Okay, and you'll be able to see that most of the time. If you can't, you can backtrack and like reverse engineer what it would have been. Okay. And then what's D?
Where you want to end.
The sequence.
It's your common difference, right? And we're going to tinker around with these a little bit more. We'll get a little bit creative. But for today, we're going to be pretty robotic about this. We're going to leave these formulas in what's called unsimplified form. And so they're just going to kind of sit there. We're going to write them and then they're just going to sit there. And then we'll play with them after we've gained a level of comfort. So that's the formula for it's an explicit formula for an arithmetic sequence. So let's go back and talk about this one, the one that was 1, 4, 7, 10, ... So for the first time ever, let's write an explicit formula. We're going to start by writing, here it goes, a sub n equals. You're going to always start your explicit formulas like that. Because I'm just saying, hey, I'm laying it out for you. I'm giving to you on a platter a little healthy formula that you could plug any number you want into, and it'll tell you what the term is. You want the 84th term? You can use this. What am I going to put in place of a sub 1? 1. And then I'm going to put plus. And this is the part that doesn't change. The n minus 1 stays put. And we'll talk about why that is. Why is it n minus 1 and not n? And it'll make perfect sense. Say again?
Because the one is right there and it's going to have different. It's so different. That's all.
Let's finish real quick and then we'll come back to that thought. What are we going to put in place of D right here?
3.
Yes, so we're just going to put times 3. So this is where it'll all come together. So if I asked you to find the 10th term, don't use the formula yet. I just want to talk to you. If I asked you to find the 10th term, this goes back to an old episode of Curious George that I watched with the kids when they were little. If I wanted you to find the 10th term and you were standing on a platform that was the first term, so you're standing on the number 1. Got it?
Mhm.
But I want you to find the 10th term. How many platforms would you have to jump?
No.
9. That's why n minus 1 is built into the formula, is because if I want to get to the 10th term, I only have to do 9 iterations of the moving process. You follow?
Yeah.
So that's where the n minus 1 sensibly comes from, is that this, once you see it, you go, oh, of course. This means I start at 1, whatever I start at. And then this means that I jump in packs of 3. And this means that I just do it 1 less time than the term number that I want to get to. So I don't want that just to be something that you see. I want it to be something that you understand logically. And at this point in time now, if we wanted to put this to use and I said, hey, let's find the 127th term. The way I would ask that of you is I would say, okay, help me find a sub 127. That's what it'll look like. And you go, oh, all right, I'm on it. And you see now why it's so handy to have that explicit formula, the purple thing sitting there, because you're like, child's play. I got this. So we're going to do 1 plus something times 3. What are we going to multiply by 3?
126.
126. And again, the logic being, I only want to move 126 times to get to the 127th space. And then you grab your electronic calculating device, unless you're not into that. What is that? 378 plus 1, 379? So if we were to go, you might want to check my math. I'm super sleep deprived. What is 360, 18, 379. So that means that if you could actually see this sequence out to the 127th position, in that position would be the number 379. And it works for going backwards as well. So backwards just meaning simple subtraction. So let's write one that has subtraction. How about we start at 56, and then we drop to negative 42, and then we drop to negative 140, and then we drop to negative 238. the first thing we want to do is verify that it is in fact arithmetic. And to do that, you just simply ask yourself, okay, what did I have to do to go from this term to this term? 56 to negative 42. I had to take away 98, right? And just in casual conversation, we're going to continue to just say subtract. We just have to, when we write the formal thing, we got to acknowledge that it's plus a negative 98, right? So if I take 98 away, if I take 98 more away again, will that get me to negative 140?
Yeah.
It will. And then test it again. If I take 98 again, will it work? Okay, so it passed the test and it is arithmetic, which means now we have to go about our merry way. So on your homework assignment, it'll say something like right underneath the problem, it'll say like find a sub 56. And again, no way are we going to do this manually. Are we going to sit there like a monkey and subtract 98 56 times? Well, 55 times. Like nobody's got time for that, right? So help me with my explicit formula. Here it goes. A sub n, always start like that, equals what?
1.
No.
Oh, at 56.
Yes. It's where am I beginning my journey? I'm standing on a platform that is the number 56, and now my journey begins by adding n minus 1 jumps of what?
Yeah.
So this in the red box is what we call an explicit formula. And now if I wanted to answer the green question and find a sub 56, I could just simply type it into my calculator as 56 plus what times negative 98? 55. Follow? Do you have any questions about the arithmetic ones? We will eventually tidy these up a little bit. We'll distribute that negative 98, combine some like terms, because there's another format that we can write these in. But I really wanted today for you to get comfortable with all this n minus 1 stuff so that we could talk about exactly that Curious George thing. If I want to get to the 40th house and I'm already at the first house, I only have to move 39 times. That's the n minus 1 idea. So let's talk about geometric real quick. So for geometric, our formula is a sub n equals a sub 1 times r to the power of n minus 1. A is just a generalized thing, Sutter, that we use when we talk about sequences. It doesn't even matter what kind of, like even if we were talking about like a Fibonacci sequence, if I said, find the 13th term, we'd still call it A13. That's just notation we use. Good question.
This is basically.
It's pure coincidence that A and arithmetic both start with A. Totally coincidence. Huh?
This is, if it's not this, it's super similar to that like super annoying equation you had us do for extra credit 2 or 3 months ago.
Right. That's all it is. That was just that. Listen, that problem about money is just a geometric sequence. Do you remember the one where you get a penny and you double it every day? It's just an exponential thing. Geometric is just an exponential. So yeah, like we could even model that using this just to show you it is exactly the same thing. So with a geometric sequence, I have this one as my first example. So let's say we did 3, 9, 27, 81, ... First off, let's check it. Is it geometric? It does pass times 3 times 3 times 3. So yes, it's geometric. So at this point, we would proceed. And I might ask you to say, find the 11th term. But before we can find the 11th term, let's presume that we want to first find the explicit formula. And so for that, you already know the cast of characters. A1 is the first term. R already. We met him 10 minutes ago. He's the common ratio. And n minus 1's not going anywhere. So to write the explicit formula for this purple sequence, we would say that a sub n equals what?
3 times
3 times 3 to the n minus 1th. And again, it's important that you differentiate that. And I know you're anxious to want to put the 11 in there, but that's not a formula. That's you using a formula. So on a test or whatever, if it says write a formula, you need to have that input slot for the n. And now, yeah, if I wanted the 11th term, I would do what Zach said. I would do 3 times 3 to the power of 10, which is quite large, by the way. 3 times 3 to the 10th is 177,147. So, and geometrics can get a little bit more confusing than arithmetics. So let's say we had a sequence like negative 0.25, comma, positive 1, comma, negative 4, comma, 16, comma, ellipses. Arithmetic sequences cannot pull this stunt off. Arithmetic sequences go one way and they just have to keep going. You can't go back and forth and back and forth. But geometric sequences can waffle. They're called an alternating sequence. And so what would make a geometric sequence go back and forth? If R is a negative value, makes perfect sense. And so we're on to you sequence. And this one, I kind of tried to keep this one in the we can do this in our head range, right? And so it may not be as obvious to everybody, like what R is from this. But most of you know how many quarters does it take to make $1? 4. So this is times negative 4. And then you validate it, it locks in when you go, oh, look, times negative 4 times negative 4. And so we can see now that we have a geometric sequence whose R value is negative 4. And now we can write an explicit formula for this guy. What's it going to be? A sub n equals what?
Negative 0.25.
Negative 0.25 times
Negative.
negative 4 to the power of. Good. Note that I put my R value in parentheses this time. It's practicing safe math is some people just use parentheses all the time. And some people like, I try to differentiate between when do I need it, when do I not. I with negatives don't screw around. So if your R value is a negative, put it in parentheses, man. Right? And close it in there. So now if I asked you to find like the 12th term, you'd have no issues at all. If I said, hey, find A12, you'd go, no problem. You'd take negative 0.25, and then you would take negative 4, and you would raise it to the power of 11. Good. Okay. You will also see geometric sequences with fractions in them, and you don't have to like love or hate fractions. We need you to be able to work functionally with them, right? So here's an example. 5 halves, 5 fourths, 5 eighths, ... Is it geometric?
Yes.
Yeah, it is. And you have to be careful because what you're going to want to say, because you're math people and math people, we think a certain way. You're going to want to say, oh, I'm dividing by 2. Like that's the normal response, but you're not allowed to speak in those terms. It's what are we multiplying by? There you go. And you could call it 0.5. I generally will work in the context, whatever the problem gives me. If it gives me fractions, I'll probably express myself in fractions. So this is times a half. I keep going times a half. I keep going times a half. No problems. So our explicit formula would be A sub n equals what?
5 times 1
Times 1/2 to the power of.
n.
No issues. And then I just have one more example. As always, this took longer than I wanted, but let's do this one more time, and then I'll give you your worksheet. Try this one. This one's a doozy. And I didn't want to try to cover every little thing today, but as we get more into this, I'll start to get into some more little nuancy, tricky things. But
You just add 4.
adding 4 to the end of the thing does not make it geometric, FYI. And those were not my words, by the way. I was quoting curls up here, but so yeah, that doesn't work for me. I know he did. He almost rendered me speechless here. Is it geometric? Well, first off, it's sure as heck not arithmetic, right?
Yeah.
Like you add 724 and then you add like holy buckets 7,240 or something. And so arithmetic, that ship sailed. Could it be geometric?
Perhaps. Sorry.
Here's what you do, right? And here's the trick. I'm sorry it took me so long to get to this because studies would show that I've long surpassed the point at which I would expect you to keep listening. But hear this. When you want to find an R value and it's not obvious, what you do is you take any term and divide them by its predecessor. So I would take on my calculator, I would take 804 and I would use a calculator for this,
How?
and I would divide it by 80. And my calculator says 10.05. So going the other way, what it means is this would have had to be multiplied by 10.05. And Anderson's on to me. He's wise to my game. And so now all you have to do to test for is it geometric or is it not is take 804 and take it for a spin and multiply it by 10.05. And you can see that that does not match what the third term is. So even though terms sometimes they look really delicious and like there's patterns, or there, yeah, there's a pattern, but having a pattern doesn't make you a geometric or an arithmetic sequence.
But it's still a sequence.
It is a sequence of some type. Lord knows what it is, but it's certainly not geometric. So do you follow what I just did? I calculated a potential R value by doing division, and then I tested that R value and it immediately failed. You can see that that's not going to work. So this one I would just simply write not geometric, go on my merry way. Again, any directions that are in a problem about write this, they all go out the window when it's not one of those two. Just sail on. Okay.
It is technically probably is a form of sequence because you get 10.05 and 10.005 and 10.0005.
That's pretty cool. That is neat. Again, it's a pattern. It's just not the kind we need, right? So let me give you assignment 41. Boy, I changed this assignment like 9 times today. It's the front page is all arithmetic, the back page is all geometric. And I don't think you'll struggle much with this at all. And there are some planted around that are like not arithmetic or not geometric. I don't remember how many, a couple on each side, something like that. Okay. Cool.
The funny thing is,